¿Qué es la que hay, mi gente? Welcome to Virtual Math Masters. I'm your boy, Master Cruz, so you never do math alone again. And today we're going to talk about solving equations by taking square roots. This is the last topic of equations world, so I hope that you enjoy it and it makes sense. Remember, you have to learn the previous ones to be able to understand this one, so here we go. Example 1a talks about me giving you x squared equals 16. Now, when we solve for a variable, we want the variable by itself. And the only reason this equation does not say x equals is because there is a 2 as an exponent, and we can read this as x squared or x raised to the second power. So how do we get x by itself? Well, we got to use inverse operations. We learned with our one-step equation, our two-step equations, that if you're adding, the inverse operation of adding is subtracting. The inverse operation of multiplication, which sometimes we use a dot for it, is division. So these are inverse operations that we use to cancel each other out. So what is the inverse operation of having a number or a variable raised to the second power? Well, take the square root. These are the inverse operations. If you have one, you're going to do the other. Almost makes sense, right? Square root. And you need to know the difference between them because they are inverse operations. So here we go. If I have the 2 up there, meaning I have x squared, the way I could cancel it is by taking the square root. But what I do on one side of the equation, because I have to keep it balanced, I have to do it on the other side of the equation. X cancels the x squared. And here's what you're going to learn, that when you take the square root of any number, right, the square root of something squared, you actually get two answers. What is the square root of 16? That means what number, when you multiply times itself, gives you 16? Well, the correct answer is 4, but that's not the only answer. You also have comma -4, because if you take +4 and you plug it back into the original expression, right? The expression was x squared. If I take this 4 and I plug it in here, so I put a 4 inside of the parentheses and I square it, I will get +16. But if I take -4 and I also square it, negative times a negative gives me a positive, so it also gives me +16. For this reason, these two are the answers, and you must give both answers in order to get the complete answer, all the points. Because if you only give me one answer, then you only get half of the credit. Now, this is not the only way that you could express this. You could also, for a short notation, you could just say plus or -4. So if you ever see a plus and a minus sign together, it's just so that you don't have to rewrite the 4 twice. And one 4 is positive and the other 4 is negative. This is what this answer is saying. So in reality, when you look at this, you have two answers, not just one, two answers, one +4 and the other answer is -4. So that's how you do example 1a. Example 1b is very similar. So if you could do it before I do it, that will be great, or at least if you could know the answer. So m is not by itself because it's being squared. And we learned that the inverse operation of something squared is to take the square root. But what you do on one side, you must do it on the other. So the square root cancels the square, and you get that m equals the square root of 81. What number times itself gives you 81? Well, that will be 9, because 9 times 9 is 81, but not just +9, also -9, right? Because -9 times -9, also +81. So hopefully this makes sense. This is the basics of solving an equation by taking the square root. Now we're going to add one more element to it, because we will have equations sometimes that require a little bit more work, like an extra step. All right, so we have x squared -1. The first step is, before we wanted to isolate the variable, now we want to isolate, so this is for problem 2, we want to isolate the squared term. And this is what we always want to do, squared term. We want to make sure that the entire term that has the square is by itself. So in this particular moment, you look at the x squared, and why is the x squared not by itself on this side of the equal sign? Well, the reason it's not by itself on that side is because, right, if you put the line over here like we did before, it's because there's a -1. On the left-hand side, the x squared is being subtracted by 1, so my inverse operation is at 1 to both sides. This cancels because -1 plus 1 is 0. We bring down the x squared, and we bring down the equal sign, and then 99 plus 1 is 100. That's perfect. The x squared, it's by itself. That's perfect because the x squared is by itself. Now I can do step 2, which is take the square root. Take the square root. The square root. And that's what I'm going to do. I'm going to take the square root on the left and the square root on the right. So what you got to learn here is that when you see a problem and you see a square, you cannot take square root right away. You have to isolate the square term. In example 1b, the first thing that we did was to take a square root because it was just m squared. There was nothing being added, subtracted, or multiplied by m. But here we had the -1, so we cancel the 1 first. And now we take the square root, and we get that x equals plus or minus 10. And that is my answer, because 10 times 10 is 100, and -10 times -10 is also 100. Okay, so example 3. How about this problem? So now we have two different things that are around the x squared. So I cannot take the square root right away. I need to cancel the 4 and I need to cancel the -1. So which one do I cancel first? Well, I want you to remember, go back to two-step equations. If there was no square, which one would you cancel first, 4 or 1? Well, you will cancel the 1 first because it doesn't have the variable. Okay, so to cancel the 1, again, I'm going to draw this line to make sure that we know the difference between the left-hand side of the equal sign and the right-hand side. I don't want to subtract 99 because I don't care about the 99. I only care about the numbers with the variable. So I'm going to add 1. I'm going to erase this, and I'm going to add 1. And what I do on the left, I do on the right, inverse operation. So I have 4x squared. Again, -1 plus 1 is 0, so it's gone. Equals 99 plus 1 is 100. This looks a little bit familiar, but in the previous problem, we just took the square root. We cannot do that because there's still a 4, and that 4 and the x squared, what are they doing? What operation are they doing together? Are they adding each other, multiplying? Well, they're multiplying because there's no plus sign in between. So the inverse operation of multiplication, we talked before, is division. And what I do on the left, I have to do on the right. The 4 divided by 4 is 1, so this cancels. And I get x squared equals 25. 100 divided by 4 is 25. On this step, now the square term is by itself, which was my goal. So now I can take the square root, finally. And when I take the square root on both sides, hopefully you can write the answer before I write it, or at least you know it in your head. X equals 5, but not just 5, plus or minus 5, because we have two answers. So remember, plus or minus 5 means that the answer is x equals 5, and the answer is also x equals -5. You can always double check these by plugging in these numbers back into the original equation. We're not going to do that for the purpose of this video. That's a different skill, but you can always plug it in and check that you get a true statement. 99 equals 99. We already did that in previous videos. So this is how you solve for a square by taking the square root. Now let's look at example 4a. Example 4a is a little bit different because it doesn't have anything squared. It actually has a root, and they want you to solve for x. So the way that you cancel the root is doing the inverse operation. Square it, right? So here we go. When I square this, check it out. I'm going to do this over here. I'm going to raise it to the second power. Let's actually write it in white so it's more, there you go. And what I do on the left, I also have to do on the right. So I raise it to the second power. We already know that the square root cancels the square, and I have x all alone by itself, and it equals, what is 4 squared? Well, 4 times 4 now is 16. So this is my answer. X equals 16, and it's just that easy. Okay, that's how we do that problem. If you plug in 16 in here, the square root of 16 is 4. It gives me back the original problem. Now be careful. There's no positive 16 or negative 16 over here because this is just 4 squared. And hopefully you remember that 4 squared just means 4 times 4. That's it. So here we go. Let's keep taking square roots. 4b, you do this one. Try it before I do it. Well, to cancel the square root, you gotta square it. I know, it's crazy. And then you take the square root, cancels with the square, and you get that x equals, but it's 8 times 8, people. 8 times 8 is 16. Not just kidding, that's 8 times 2. So do not make the mistake, all right? If you said 64, that's perfect. Do not make that mistake. This is 64 because that's what 8 squared is. Just a quick refresher. Again, a square means 8 times 8, not 8 plus 8 or 8 times 2. It is 8 times 8. All right, example 5. We're almost done with this skill. Same idea. I want to square it, but I can't square this right now because the square root is not by itself. So when I'm solving for square roots, the first step is to isolate, just like before, isolate the square root. Okay, so we just do the same thing backwards. How can we isolate the square root? Well, what number is on the same side as the square root? Well, 3. We need to cancel 3. The inverse operation of adding 3 is subtracting 3. So this is going to cancel. And we just drop the square root of x. We drop the equal sign and simplify. 10 minus 3 is 7. And then we square both sides. So here we're going to squared and squared. And so you have that x, just x, right? Just x equals 7 squared is 49. So this is 49 right here. And that is the answer for example 5. Now let's go into our last example. The last example, it looks like is elaborated, and then I'm going to do a bonus example, I guess, and I'm going to write it so I don't forget about it. This is going to be the square root. Let me see. X squared equals negative 100. That's going to be our example. All right, so that's the bonus example, but that's not the example that we're doing right now. The example that we're doing right now is this one. All right, so let's do it. Is the square root by itself? No. So the first step is to get the square root by itself, which means I need to cancel every single number around it. So I want you to look at this as one variable, just as one x, one blob. I don't want you to look inside of it. I just want to see it like you need to cancel everything around that. So what would you do if the whole thing was an x? What number would you cancel first? Well, you'll cancel first this 2, right? So instead of subtracting 2, we're going to add 2 to both sides. And if we do that, we drop everything else, right? So the 2, the whole blob, that we don't care what it is, we just care that it's a square root, so we write it down. Negative 2 plus 2 is 0. We drop the equal sign, and this is 8. And then we continue. Can I square now? I cannot, because the square root is not by itself. It has this 2 now. What is the square root under 2 doing? Well, when you have a number in front of a square root and there's no plus sign in between or minus sign in between, we assume that it's multiplication. So when you have numbers next to variables, next to square roots, it's just multiplication. So the inverse operation is division. I'm going to divide everything by that number, whatever that number is. This 2 cancels, and I drop down my square root again. Don't care what's inside. I just care that it's a square root. Sorry, 3x minus 1. You have to write exactly what's in there. Equals 8 divided by 2, 4. So now when I look at this, the entire square root is by itself, meaning that there's nothing around it. Everything that's there is inside of it. So because it's inside, now I can square. Okay, so now I do my second step, which is square both sides. So the first step was to isolate for the square root. The second step is to square both sides. So that's exactly what I'm going to do. I'm just going to square both sides. What I do on the left, I also do on the right. I know that the square will cancel the square root. So I'm going to get 3x minus 1 equals. Now be very careful now, because I'm taking a square root, or I'm squaring it, sorry. So 4 squared is 16. So 4 squared is 16. And then I solve this like a one-step equation. I will add 1 to both sides. This cancels. And I get 3x equals 17. Then the last step is to divide by 3 on both sides. And you can quickly see that 17 does not divide by 3. So that is my answer. My answer is x equals 17 over 3. It is okay for you to get fractions. There's nothing wrong with fractions. You don't need to convert it into a decimal. You just leave it like that. That's an exact answer. If I were to convert this to a decimal, it will be a non-terminating decimal. That will be 5.6667, I believe. Like it keeps going, repeating the 6 forever. So we want exact answers. If I don't ask it around, you just leave it like that. Now, the last example that I want to give you is this. Although you're not going to talk about this, or you may not talk about this depending on the class that you are, it's very important that you are aware of this. Usually in Algebra 1, we mention it, but we don't work with them. In Algebra 2 and beyond, so 11th grade and beyond, you will work with them. But did you know that there were imaginary numbers? There are numbers that are real and there are numbers that are fake, like your fake friends. You know, fake friends, that they're really your friends. So they're fake numbers, but we don't call them fake numbers. We call it imaginary numbers. Remember, let's solve this problem. If I ask you to solve this problem, you will have to take the square root, right? Because it's the inverse operation of something square is a square root. And I will have to cancel this with this. And then my answer will be x equals, I'll have to find a number. Now, when I multiply it times itself, actually, let's make this problem way easier. I'm not going to make it 100. I'm going to make it -1. Okay, I changed the problem, erase the zeros. We're going to make it -1 to make it easy because it's the first time you see it. I need to find a number that when I multiply it times itself gives me -1. All right. Well, what number can I multiply to itself? You could say +1, but 1 times 1 equals 1. Then you could tell me, how about -1? Well, -1 times -1 also gives me +1. And you can say, well, what about 1 times -1? Whoa, we can't do that because when we take the square root, you have to multiply the same number times itself. Therefore, there's no number, yet you could solve for it. So we call this I. The square root of -1, the square root of -1 is an imaginary number. All right, this is imaginary, and there's a bunch of memes about imaginary numbers, if I can spell correctly, and irrational numbers. But that's where that I comes from, because it's imaginary, okay? So this is something good to know. We might play around with imaginary numbers later on this year, or maybe in years up to come, but this is how you solve a square root. It's important that if you get a problem like this, all you have to say is you stop right there and you say no real solutions. That's all that means. Just say no real solutions. That will be the answer to your problem. For example, if I were to solve any of these problems, and on this stage, I would have gotten something like x squared equals -16. If that number is negative, no, imaginary, there's no solution. There's no solution. If this 81 was negative, there's no solution. If this 100 was negative, there's no solution, because an x squared cannot equal a negative number. I hope that makes sense. This was Master Cruz with Virtual Math Masters, so you never do math alone again. I hope this helps. And if you need any questions, if you have any questions and need extra help, please comment below, send me an email, or join our Virtual Math Masters community for ongoing help. Have a great day.